Hello, welcome back. Today we're going to be factoring perfect squares and a difference of squares. The objective is by the end of this video, you can factor this thing called a perfect square trinomial, and you can factor a difference of squares. We're going to go ahead and factor the following trinomial, 4x squared plus 20x plus 25. And what I want you to notice is that the first term, 4x squared, and the last term, 25, have square roots. In other words, the square root of 4x squared is 2x, because 2x times 2x is 4x squared. And the square root of 25 is 5. Anytime this happens, it's a good idea to go ahead and split up your factors of 4x squared as 2x and 2x. The 25 we can split up into 5 and 5. Now when we multiply that out, 2x times 2x gives us 4x squared. 2x times 5 gives us 10x, 2x times 5, 10x, and 5 times 5 is 25. Notice that when we split up these two into their square roots, 2x, 2x, 5, and 5, it gives us the correct factorization because we know 4x squared plus 10x is plus 20x, plus 25 gives us our original expression. So our factors are x plus 5 and 2x plus 5. Now this doesn't always happen, but there's a good chance, again, that if you're given a trinomial whose first and last terms can be square rooted, it's just going to split up into the square root of the first term plus or minus the square root of the second. Now go ahead and on your own, try to factor this trinomial, noticing that the first term and the last term have square roots. Pause the video, work it out, and press play when you're ready to see the answer. So again, anytime our first and last term have square roots, it's a good idea to start off your guessing and checking with the square roots of the first term and square root of the last term. So we're going to do 3a and 3a to give us 9a squared, and 4 and 4 to give us 16. 3a times 3a is 9a squared. 3a times 4 is 12a. 3a times 4 is 12a. And 4 times 4 is 16. Now, you'll notice when we add 12a and 12a, it gives us positive 24a, not negative 24. Well, we can change this up just a little bit by making the positive 4s both negative, which is going to change this to negative 4 times 3a, which is negative 12a. 3a times negative 4, going to give us negative 12a. It's going to change it up so that our middle terms add up to negative 24a, but negative 4 times negative 4 is still positive 16. So what I want you to notice is that when you have square roots at the first and last term, start your guessing and checking with the square roots of each. And a lot of times you'll find out that you find the right answer right away. So our factors are 3a minus 4 and 3a minus 4. One last note on this type of problem. If you have two of the same factor, 3a minus 4, 3a minus 4, we can write that as 3a minus 4 quantity squared. And actually that's how you'll see it written most of the time. So the definition of a perfect square trinomial is a trinomial that factors to be two of the same binomial, such as in the previous example. What I want you to do is go ahead and try to factor the following trinomial, 100m squared minus 60m plus 9, and see if it is indeed a perfect square trinomial like the previous example. Alright, just like the previous one, what we're going to do is we're going to split up that 100m squared as 10m and 10m. So 10m, 10m, and we're going to factor the 9 as 3 and 3. Now notice it's going to be a negative 60m in the middle, so I'm going to make that negative 3 and negative 3. So 10m times 10m is 100m squared. 10m times negative 3 is negative 30m. Negative 3 times 10m is negative 30m. And negative 3 times negative 3 is a positive 9. So when we combine our like terms, we get 100m squared minus 60m plus 9, which is indeed our original expression. So we know we factored correctly. And our factors are 10m minus 3, 10m minus 3, which is the same thing as 10m minus 3 squared. Since we ended up with two of the exact same factor, we know that 100m squared minus 60m plus 9 is a perfect square trinomial. So this leads us to the definition of a difference of squares. The word difference meaning subtraction, squares meaning something you can take the square root of. So there are two terms that are perfect squares, meaning they have whole number square roots, and that are separated by a minus sign. Now what we're going to do is we're going to factor some problems that look like this. Now, just like in the previous examples, notice that the first term and the last term both have whole number square roots. So 4x squared factors into 2x and 2x. 25 can factor into 5. But what's missing in this is there's no middle term. So I'm going to rewrite this to make it look more like something we've seen in the past. I'm going to write it as 4x squared plus no x's in the middle minus 25. And just like in the previous examples, I'm going to split up the 4x squared into 2x and 2x. And I'm going to split up the 25 into 5 and 5. But notice it is a negative 25, so one of those 5's has to be negative. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 2x times 5 is 10x. Negative 5 times 5 is negative 25. So notice that positive 10 and negative 10x's combine to give us 0x's, which is exactly what we want. So our factors are 2x plus 5 and 2x minus 5. Now the reason this works is when we added up the negative 10 and the positive 10, we got 0x's in the middle. We were able to do that because it was a negative 25, meaning that our 5's had to be the same but different signs. If we go to this problem right here, 4x squared plus 25, and we start trying to factor it, suppose you want to try 2x and 2x again. We're going to find out in a moment that this particular expression will not factor. So we try 5 and 5 because they have to multiply to give us positive 25. So 2x times 2x is 4x squared. 2x times 5 is 10x. 2x times 5 is 10x. And 5 times 5 is 25. Notice 10x plus 10x is 20x, not 0x's. The reason that happens is because this is a positive 25, and the factors have to be the same and the same sign. So you might be thinking, well, can't we make that negative 5 and negative 5 instead? Well, that's just going to give us negative 10x and negative 10x, which adds up to be negative 20x, not 0x in the middle. So again, we cannot factor it. Suppose you think, oh, 4x and x, but when you multiply 4x and x times anything else with positives or both negatives, it's still not going to give you 0 in the middle. I encourage you to go ahead and try it out, see if you can find a factor that works. But I'm going to tell you right now, in the end, you're going to find out that this particular expression is prime, meaning that we're not able to factor it using whole number factors. Right, go ahead and try to factor the following, pressing pause and press play when you're ready to see the answer. Now for the first one, you notice you do have two terms that can be square rooted, but they're separated by a plus sign. And we're never going to be able to add two numbers to give us 0x's in the middle if this is a plus 16. Now, I know you probably could have tried that out, but in the end, you're going to find out that this one is prime. Now over here, we've got 9x squared minus 16. It's a little bit different. Again, since both these things are square roots, my first attempt at guessing is going to be to make them positive 3x and positive 3x, positive 4 and negative 4. 3x times 3x is 9x squared. Negative 4 times 3x is negative 12x. 3x times 4 is 12x. And 4 times negative 4 is negative 16. When we combine our like terms, we're left with 9x squared minus 16 because the negative 12 and 12 cancel out. So that means our factors are 3x plus 4 and 3x minus 4. What I want you to see from this in the end is that if both of these are perfect squares, meaning they can be square rooted into whole numbers, we can forego all of this middle step right here straight down into splitting the 9 into 3x and 3x and the 16 into positive 4 and negative 4. And then if we want to, we can go ahead and distribute them to check our answer. Now go ahead and try to factor the following. These are a little bit different than the previous ones. That's on purpose. Just see if you can notice the pattern. Pressing pause and press play when you're ready to see the answer. Now for the first one, I got n plus 2 and n minus 2 because n times n is n squared. And that was a little bit different because you had to split the n squared into two different n's without a leading coefficient at all. Now 81 minus 100h squared, you can get 9 minus 10h and 9 plus 10h. Depending on the expectations, you may not have wanted to factor it that way. There is another way to factor it. It requires a little bit more work, and let me show you that real quick. We can change the order of 81 minus 100h squared to make it 100h squared plus 81. And then we can factor a negative 1 out of that term, giving us positive 100h squared minus 81. Then we can go and factor it further by factoring the 100h squared into 10h and 10h, and the negative 81 into plus 9 and minus 9. Either one of those answers is acceptable to me.